look at these points and decide whether it's an absolute max, absolute min, or neither. An absolute max means literally the highest point. So x1 is the absolute max. If you look at that, it's like hiking. That's higher than everywhere else. Where's the absolute min? That's at x4. It's the smallest or the lowest points, and then these are neither.
Um,
Does that make sense?
Yeah, it's pretty easy. Neither. Okay.
All right. So wish they were all that easy.
Yeah.
They're not. So there is a recipe to doing these. So they're going to give you a function, and you have to evaluate the function at both endpoints. Okay. Um, that's the first thing you do in the next few problems here. So as review, it's always a good idea to put that number in parentheses when you're substituting in for the variable, like that. So I would encourage you to do the calculations with me, as I may make some mistakes. Just like we found out yesterday, sometimes I don't get the right number. Where is the syntax error? Okay, there it is. All right. Round 2 decimal places needed. All right, so I got like 49.17 for that one.
That makes
And minus 0.33 for the second one there. I'm rounding because it says to round. Otherwise, I'd convert it to a fraction. Just make sure 1/3 x cubed plus 5 over 2x squared minus 6x minus 1. Okay. So the next thing you do is you take a derivative of that function that you're given.
okay.
That's where all this, derivative stuff that we've been talking about comes into play here.
Oh,
So your derivative here is 1/3 times 3x squared plus 5/2 times 2x to the power of 1 minus 6. And that reduces to x squared plus 5x minus 6. You set this equal to 0. So this is where you're going to want to factor or graph or use one of those techniques you learned in a previous course. So
okay.
here you're looking for two numbers that multiply to minus 6, but add to positive 5, plus 6, and then minus 1, like that.
Yeah.
And then you set those both equal to 0 here. So you get -6 and positive 1. And you then check, this is very important, you check to see if either of those are in that interval from -7 to 2. And they both happen to be in there. Sometimes only one is in there, sometimes neither are in there, but actually usually there's at least one in there. So then you go back and you evaluate the original function at those two critical points. So you use the derivative, you set it equal to 0 to find what are called these critical points. And then you put those back into the original function. So we got to go back and do more calculating here. So at 1, I get minus 4.17. At -6, I get 53. Right. So now we can actually figure out the answer. Like you have to do all that to be able to fill in these boxes up here as appropriate. So there is an absolute maximum. And it asks two questions. The first one is like, what is the max, which is 53. This is the absolute max here. And then the second question asks, where is it? That's the X value. Then the second part says, well, what's the absolute min? Well, the absolute min is right here. It's minus 4.17, and that occurs at x equals 1. Like,
Okay.
So it's two questions. It's like, what is it and where is it? The where is the X value, the what is the Y value.
Okay.
So the other way to do this, which maybe will be more helpful on the test, is you could graph this function in the window, and you might find that that's easier. But for now, this is probably our best approach. Okay,
Okay.
so rinse and repeat here. We're going to do the same thing. They give you another function. They give you another interval. You've got to find f of -6 and f of 6. So back to the calculator. Why do I keep making this? All right. So first one there is -509. And then 6 is going to be the same. It's also -509. So the idea here is that at these two values, like we don't know what happens between, we don't know if it goes up, comes down, goes up. We don't have any idea. We just know these 2 points on the graph. So that's why you have to take a derivative. All right. So
Okay.
the original function there, let me grab another snip of it. All right, so we're gonna be able to take the derivative of this. That's 4x cubed minus 100x. The derivative of -5 is 0. You'd set this equal to 0. And then you factor out anything that's common in between them. So if you factor out a 4x, you get x squared minus 25. And you have to set each of these equal to 0. So you're setting 4x equal to 0, x squared minus 25 equal to 0. So there's the critical point at 0. And then this on the right gives you 2 critical points of 5 and -5. Any questions on how to solve that one?
No.
Okay. So now we go back to the original function and we try these critical points. So we try 0, 5, and -5. And they all fall in that window that they give you. They give you a window of -6 to 6. So if they didn't, you would exclude them. All right, so at 0, it's -5. At 5, it's -630. And same with uh, -5 here. Uh, I'd like to really quickly show you how to do this in your calculator fast, if you
Okay.
would like.
Okay.
Let me grab the calculator here. Okay, I should be sharing the calculator now. There it is. Okay. So what I'm doing here is I'm using the STO button. So like let's just say I wanted to do -6 like from the beginning. You do an STO, which is store down here to X. And then you can write in the function X to the fourth, okay, -50x squared -5. And it knows to use that X value. So this is option 1 to do this.
Okay.
Have you seen this before?
Yeah. I think
Okay.
so.
The other option is to put the function in for y1. And this is all to try and save time. It's for you and ease of calculation. Um, is you uh, you enter the function, you don't graph it. So you actually go to table, which is second graph, and you'll see there that it's giving you the y values for those x values. So you just
Okay.
that's another way to do it to save you time.
Oh, okay.
So, I mean, up to you. You know, you might want to practice one or two, but that would definitely be worth looking at one more time to help you out here. All right. So the if we go back to our problem here, the absolute maximum is -5. So the max can be a negative, and that occurs when x is 0. The minimum occurs when x is 5. Sorry, the absolute minimum is -630, and it occurs when x is 5 or -5. So we're looking for the smallest number in this list, the biggest number in this list, and that's how we're answering this question.
Okay. Let's see. No,
All right. Any thoughts on that before we proceed?
no, that seems easy enough.
Okay. All right, new question here. So again, you want to evaluate at the two endpoints, f of 0, f of 4. So sometimes they're not too bad to do by hands. This first one becomes 6/4, which is 3/2 or 1.5. F of 4 is 2/8, which is 0.25. All right, so then you have to take a derivative, and this is where it gets, you got to remember all your derivative rules from before. So f of x equals 6 minus x over 4 plus x. So this is a quotient rule problem. There's a top and there's a bottom. So the derivative of the top is -1. So the derivative of 6 is 0, negative x is -1. On the right here, the derivative of 4 is 0, derivative of x is 1. And so the derivative rule is one you got to remember. It's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And then we just start filling in with those u's and v's, or bottoms and tops. So you got 4 plus x times -1 minus 6 minus x times 1 over 4 plus x squared. And then we need to simplify here. So in the top, this -1 here gets distributed into both. So that's -4 minus x. And then on the right, same thing here, -6 plus x all over 4 plus x squared. And you see that the x's actually cancel, which is good and bad. So this does not have any critical points. And the reason is there's nowhere where this thing equals 0 because there's no x in the top. So if you get this on the test, you actually know to just use these 2 points to answer the question. There's no critical points to evaluate, and you just use these 2 points here. So the max, start with the max. The max is 1.5, and that occurs when x equals 0. And the min is 0.25, and that occurs when x equals 4. All right, moving along to next one here. Okay, they give you some function and they say that x is greater than or equal to 5. You should always evaluate at the endpoint. Like that's always a good place to start. So I'll do that as well. And then it's the same recipe as before. You take a derivative, you set it equal to 0, you find the critical points, and then you evaluate at those critical points. So let me evaluate this. Minus x cubed plus 9x squared plus 120x minus 200. All right, so that ends up being 500. Now this one you gotta be really careful here. It says the total profit P of X in thousands of dollars. So this is actually 500,000.
Okay.
Okay, and that will be important when we put the answer in. So
Okay.
next thing is to take a derivative, e prime of x. So we're just using that power rule over and over again. Derivative of minus x cubed is minus 3x squared. The derivative of 9x squared is 18x. The derivative of 120x is 120. All right, so this is a little more challenging to find the critical points, but if you factor out the GCF, which is minus 3, 40, not 20, 40, it becomes more manageable. So now you're looking for two numbers that multiply to negative 40, but add to negative 6.
10 and 4.
Yeah, perfect. So x minus 10, x plus 4. You don't really care about this 3 on the outside. You'd set each of these factors equal to 0.
So you don't
And so
have
you
to
get,
do anything with the 3.
yeah, you ignore it.
Okay.
Okay. Now, again, this is the first time that domain has really mattered. See how it says x greater than or equal to 5? You cannot use this point on the right because it does not fall in the domain. All right, so this 10, we now have to go back and check in the original. You have 10. And see here. That's 900. So that really means 900,000. So if we go back, it says the maximum profit is, so that first box is the 900,000 when 100,000 tires are sold.
Okay.
Any thoughts on that or proceed?
Yeah, we can go ahead. Oh,
Okay,
and we need to practice. So.
yeah, right. So this one again, you can read the words if you want. I mean, I don't know, maybe you're interested in the number of fish swimming upstream. Yeah, I'm not, but you are. The You always evaluate the function at the two endpoints, f of 5 and f of 19. So we'll get to that. For some reason, they want you to take the derivative first and enter the derivative in. That's fine. Um, but it's going to occur, the maximum of fish is going to occur at either one of the endpoints or where the derivative equals 0, like over and over and over again, the same thing.
Okay.
So let's first evaluate the function at the endpoints, and then we'll take a derivative, set it equal to 0, and you're seeing the same things over and over here again. Times x plus 4796. Okay, this one stayed around. All right, so 5 is 6733.5, 19, 6971.5, like that. And then you got to take your derivative. So your derivative here, again, power rule 3x squared, bring that exponent down. 4.5x worth of 2 times 4.5 is 9x plus 390, like that. So that is the box for that there. So then you are setting the derivative equal to 0. And again, if you can, you try to factor out a GCF, which in this case, you hope it's the first number. That really helps when it's the first number. Okay, so two numbers that multiply to minus 130, add to negative 3. You were on the right track in this last problem. You always try like 10 is a good one to always try. In this case, it's 10 and 13. So you said each of those equal to 0. And then you have to decide, do these numbers fall in the domain? Do they match your filter?
-10 doesn't, but 13 does.
Yeah. So you go back and try f of 13. And often, but not always, it is at the critical point. But, assumptions are dangerous. So it would appear that this is, this is the answer. And it is, but just, don't make the assumption that, well, it's probably always at the critical point. You really are supposed to check them all. Um, Now this one just wants the X value. X represents temperature, 1 degree Celsius. So it is 13 degrees Celsius. And I have no idea if that's true. Maybe it is. Okay, moving along here. All right, for a certain automobile, this represents the miles per gallon obtained at a speed of X miles per hour. Um, this is actually an interesting problem for most people. They don't realize their fuel economy is better the slower they drive. Um, but then you don't get there as quickly, so we got to consider that as well. So again, you want to evaluate at the two endpoints, and then we're again going to take a derivative, set it equal to 0, and evaluate there. But the first thing is to evaluate at 30 and to evaluate at 60 there. X equals 30. $18.9. Let's double check that those are the right equations. Squared is 1.34x minus 7.5. Okay. Now we're going to take a derivative. So the derivative of the first one is negative 0.015 times 2x to the power of 1 plus 1.34. So let's multiply that together. So it's minus 0.03x plus 1.34 equals 0. And you solve for x, 1.34 over minus 0.03. And that ends up being not a whole number. Why would they do that? Let me make sure I didn't make a mistake here. Times 0.03. Huh. Well, this ends up being 44.66 repeating. I'm going to go out to 4 decimal places on that. And that's what we're going to evaluate M at. This is round to the nearest thousand. Okay, so we're in good shape with that. So that ends up being 22.427. So the answer here is that the maximum miles per gallon is 22.427 at 44.667 miles per hour. So nearest thousandth means 3 decimal places. And then the minimum is 18.9. That's the smallest number there in the list. And this occurs at 60 miles per hour. I think I skipped the problem, so I do
Yeah.
apologize. See that now.
Yeah, but that's okay.
All right, let's get back to it.
I didn't get the last box. That was my bad.
Sorry.
60, that's what I thought. Okay, sorry.
All right. Right. New question here, something about a marsh, whatever. We got again, it's kind of the same thing. You got to check the two endpoints. Um, so we'll do that, and then we'll take a derivative. Little thing on the derivative. Let's get these evaluated first. So we got x squared, x squared is 36 divided by 2x. So that's 18.5. And then that's 7.5. So now we got to take a derivative. One of the things about this one is actually there's a shortcut to taking the derivative. You can actually divide both by the 2x, both the top terms, and that'll save you a little bit of effort on the derivative. So the reason that helps so much is that one of those x's on the top cancels one on the bottom. Over on the right, 36 and 2. So you end up getting 1/2 x plus 18 over x. That can be written as 1/2 x plus 18 to the x minus 1 power. So the derivative is much easier when it's in this form. The derivative is 1/2 x, or I'm sorry, 1/2. That's the coefficient. And then you bring this negative exponent down. So it's minus 18 x to the minus 2. Or you can write it as 1/2 minus 18 over x squared. But that's your derivative for that. Is that okay so far? Is that okay?
Oh yeah, I sorry, I don't
Okay.
know.
Yeah, sometimes I don't hear. But that's this first box here. We still have to set it equal to 0. 1/2 minus 18 over x squared equals 0. When you solve this, you'll find that x is plus or minus 6. So the 6 is the only one that fits in this window. So you go back to evaluating it at 6, and all right, you end up getting 6. Okay. So the minimum is after 6 months. That's the x value. And the minimum percent of element will be 6%. That's the y value. Okay, we can move on to the next one now. This one's kind of nice. They step you through all the steps uh, to answer it. So if they're all like this, they wouldn't be all that difficult. They're telling you what to do. You can read the problem if you want, but they're saying take this, take this x plus 1 equals 10 and solve for y. Well, you know that y, you just subtract x from both sides. It's 110 minus x when you solve that equation for y. So that's the first box there. For part B, they're saying use this equation p equals xy and substitute 110 minus x in for y. So this is x times 110 minus x, which is 110x minus x squared. That's your second second box there. Now part C, they're asking you to figure out, well, what's the domain of P found in part B? You're actually setting the factored form equal to 0, so x equals 0, 110 minus x equals 0, and you'll find that it's 0 to 110. The reason is, again, like they're saying, hey, two numbers that add to 110, excuse me, so either one is 0 and the other's 110, or the first one's 110 and the other one is 0. So the domain here is parentheses. Actually, let me write over here. Parentheses 0 to 110. Actually, they can be included, so it's bracket. All right, so that's part C. Part D is to take the derivative of this 110x minus x squared. So, okay, yeah. So the derivative of this is 110 minus 2x. That's the first box in there. And then you have to set it equal to 0. So when you set it equal to 0, you find that x is 55. That's the second box there.
Okay.
Is that okay?
Yeah.
All right. There were two solutions in part B. No, there was one solution in part B, part D. For that solution. So then they're in part D, they're saying to evaluate that P of 55. So that's back in the original function in right here in part B. So it's 110 times 55 minus 55 squared.
Okay.
So let's calculate that. 110 times 55 minus 55 squared. So that's 3025. So that's the answer there, 3025. So now when you evaluate the lower end point, so when you evaluate P of 0 and then P of 110, you find that they're both 0.
Okay.
Which is obviously not going to work here. All right, so we know that the it's maximum of 3025 when x is 55, and the y value is also 55. You get that from just sort of looking at the fact x plus y has to equal 110. So if x is 55, then y must also be 55.
Okay.
All right, any thoughts on that before we proceed?
No, I don't think so.
Okay, next one's really similar. Keep going here.
Another long, fun one.
Yeah. Yep. But they're stepping you through it again. So the first thing is to solve this equation for y. Y is 93 minus x. This time though, it's just the part on the right of the equal sign that they want in the box there. And then you're putting that in for y. So instead of y, it's 93 minus x, 93x squared minus x cubed.
Okay.
So that is the second box there for part B. Label these better. Okay. Find the domain. So it's kind of the same issue. Like if x is 0, y has to be 93. If x is 93, y has to be 0, because they add up to 93. So that's your domain. It's from 0 to 93. And you do want to use those brackets. For part B, you're taking the derivative of what you wrote in part B. So your derivative is 93 times 2x minus 3x squared, 186x minus 3x squared. That's that box there for part B.
Okay.
915. Okay. And then you have to set it equal to 0. 186 minus 3x squared equals 0. So you end up getting x squared equals 64. No. The Why am I struggling? What's 186? What's 186 divided by 3? 62. Huh. This isn't working out. I'm sort of stumbling here. Um,
Mm.
what am I doing wrong here? It doesn't say that. It doesn't say to separate the answers. When you put your cursor in that box there for x equals, does the square root tool come up?
It has that as one of the options. Yeah.
Okay. So the answer here, it ends up being the square root of 62. Um, I feel like there's something that's wrong here. Let me just double check.
Okay.
93x squared. 2 times 93 is 186 minus 3x squared. Okay, that I see what the issue is. Boy, I am struggling today. Okay. All right. So you actually factor out a 3 from both. So that becomes 62. I'm sorry, as sorry, you factor out 3x. 62 minus x equals 0. And then you set both of those equal to 0. And x is 62 and x is 0. Um, so there are two. So you have to just put in 0, comma 2 for your answer there.
Okay.
All right, but wait, there's more. Okay. So part E, never ending problem. All right. Part E, uh, so you're evaluating the original function, which is way back up here. It's this 93x squared minus x cubed. It's x squared. Yeah. Okay, so you're evaluating it at 0. So P of 0 ends up being 0. P of 62, we're going to evaluate that. So that's 93, 2 here. 93 times x squared minus x cubed. Big number, 119,164. And then P of 93 equals 0 again. And this should look familiar. Like we've been doing this like the entire lesson, checking the two endpoints, then taking the derivative setting equals zero,
Hmm.
then evaluating that. Like even if you don't fully understand all the details, this macro level view of what we've been doing should be clear. I've got to evaluate the endpoints. I got to take a derivative set equals zero and then
Right.
evaluate. The maximum value is 119,164. It occurs when X is 62. Now to find Y, remember Y was, or X plus Y equals 93. So Y will be 30, 31.
Okay.
Okay. All right. One, two, yeah. So fortunately, we're not going to be able to get through all of this.
Okay.
Get through, sure, we'll get through this question.
I can go back. I can like exit out and go back, right?
Right. Yeah. I mean, yeah. So if you want to, we'd only need like a half hour to finish this up.
Okay.
Um, and well, I'll ask you when you're done. I can open something tomorrow for you if we need to. So the revenue function, revenue is price times quantity. So it ends up being 156 minus x over 10 times x. Sorry, I guess the x should go on the other side. So this is P, this is Q. Oh, that's a bad Q. So that ends up being 156x minus x squared over 10. That's your first box. Price times quantity. Okay. This one's got another one of these things where it's, X thousand candy bars, but they just want the X value, so you're okay. Um, you've got to just be careful in these problems that you're not off by 1,000. So to do part B, you have to take a derivative. So a way to rewrite is 1 over 10 x squared. So your derivative is 156 minus 2 over 10 x. You set that equal to 0. Divided by or times 5. All right, so you end up getting x equals 780 when you solve that. And then to find the maximum revenue, you have to put this 780 back in the profit function there, or the revenue function. So the revenue function 780 equals 156 times 780 minus 780 squared over 10. And you end up getting 60,840 for that third box there for the maximum revenue. So the truth is the other three problems are probably in Chegg if you wanted to look those up. You might even get, number for number answers. Or, we need another 15, 20 minutes to finish it up.
Okay.
So I'm going to go ahead and stop there though for today.